Here we go. You're going to have two problems like this on Friday's quiz, so I thought it'd be a good DOM to do. You cannot do the numerator and denominator stuff until you simplify the entire numerator and denominator by themselves first. So, if you look at the numerator first, what comes first? Multiplication or exponents? Exponents. Nope. 3 squared is 9. B squared is B squared. So 2b times all of that over 3b to the negative 3. Now we have to multiply on the top. So that becomes
18.
And then what happens to my b's, Tyler?
They cancel?
Nay. 1b and 2b's combine to make 3b's. Now what happens to the b to the negative 3? Who can tell me that?
They change it to a positive.
When what happens? You do change it to a positive. What do you have to do to it first? You gotta flip it to the top. Everything with a negative exponent flips where it is. Now, one of the big reasons I made this to Dom, if you look, 3b, 3b, I wanted you to show the difference. Here, the squared went to both of them. Here, the negative 3 only goes with the b. Why? What's the difference? What's the difference between this 3b and that 3b? What?
One has a negative 3, you got a cube.
Do I need to cough it again?
Negative 6.
Parentheses.
Parentheses.
Okay. The squared goes to both of these because the 3b is in parentheses. This is not, so the negative 3 is just with the b. So, that negative 3b goes to the top, and you're left with 18b cubed. Oh, what's this? Another b cubed. All over 3. Now what's 18 divided by 3?
6.
That's right. And your two b cubes form a b to the
3rd. 0. 6.
6. That's right. Okay. Whew.
Did I say 6?
Yes. No, it's 6 b to the 6. 6b to the 6.
Oh.
When you multiply common bases, you add the exponents. Multiply common bases, add the exponents. Questions? No?
No, sir.
Man, so respectful today. Okay. Today we're dealing with polynomials. Those are monomials, one big term. Notice there's no pluses or minuses in there.
Just let you know, I don't know how you got that, but let's just go with it.
Oh, would you like for us to go over it again? Okay. First thing you had to do is the exponent, or the square. So we squared the 3 and squared the b. That's where this came from. And that's all we did. See that?
Yeah.
Then we went ahead and multiplied in the top. 2 times 9, 18. B to the first times b to the second, b to the third. Just add the exponents. That's how I got.
How's it 3? You said 1 times 2.
No. You multiply them when it's like power to a power. You add them when you're multiplying common bases. That's why over here we didn't multiply them here. We added them here. Same thing. You're multiplying common bases, so you just add the exponents. So that took us here. The negative exponent brought this to the top, which is where this came from. 18 divided by 3 was 6. B to the third times b to the third is b to the 6th.
Okay.
Feel better?
Yep.
Awesome. Okay. So today we're dealing with polynomials, which are actually easier than monomials in my opinion. Let's see, exit drawing mode, and next slide. Alright, polynomials are anything like x to the 4th, I'm not drawing on here, x to the 4th minus 3x cubed plus 2x squared, etc., etc. Every polynomial has what they call a degree. The degree of the polynomial is just the highest exponent, which I may or may not have drawn a big arrow to just now. What would the degree of this polynomial be? That's right, it would be 4. And it's just that simple. Find the biggest exponent, that's what it is. Now there are occasions where in a polynomial you might have a piece with 2 variables. Like the last one now, x squared y cubed. That's fine. That doesn't cause us any problems. But whenever you have multiple variables in one monomial, then you have to add those to get the degree. So what would the degree be now? Yeah, you just 2 and the 3, it'd be 5. That's right, you add the exponents and it'd be 5.
Right?
No, if I just asked for the degree, it would just be 5. Just the highest exponent. You can have as many variables as you want in polynomials. The only two things you can't have are a variable in the denominator. That's a no-no. And you cannot have a variable under a radical. That is another no-no. Those are the only two things you can't have. Variable in the denominator, variable in the radical. Does anybody else think this looks like the monster from Return of the Jedi?
That was like a bunch
He's about to eat Luke.
Yeah.
Yeah, he is. He does. All right, here we go. It was Jabba's pet. So, your first 6 questions today, and you are 2 of your quiz questions on Friday. 2 of them are just these. It's going to say, is it a polynomial? And if it is, what's the degree? What about number 4? What do you think?
Well, if it ain't,
Then you just say no.
yes.
Yes or no.
Number
Well,
6 is number 6.
I hear what you're saying.
First of all, is it a polynomial?
Yeah.
No.
Yes.
I told you.
It doesn't matter. The only thing that's going to prevent it from being a polynomial is a variable under a radical or a variable in the denominator. That is the only thing that will cause it to not be. Neither of those occur on number 4, so that would be yes. And what's the highest exponent?
5.
You're thinking coefficient. 1 would be the highest exponent, like power.
Where's the 1?
Well, if there's none there, then you assume it's a 1.
Oh, I see.
So that would be yes, and it has a degree of 1. What do you think about number 5, Tyler?
Yeah.
That's right. And what would the degree be?
3.
Very good. Now, a lot of people tend to look at this and say, whoa, 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 whoa. You just said no fractions. I said you can't have the variable in the denominator. But that fraction is just a number, and the variable is not touched by it.
So 6 is no then.
That's correct. Why not?
Because it has 2
Variables
yeah.
in the chromometer.
Denominator.
Here you go.
Bam.
Okay. Let's see if we can do some more of those. All right. Hit the next slide.
First one, no.
Blue, what do you think about number 16? Yay or nay? Why?
Yay.
Why?
Yay.
I'm talking to Blue.
Okay.
Why do you think no?
I could barely see.
Well, there's a seat up here if you want to sit closer. Okay. But you can barely see it, which means you can see it. So, why no? Is there a variable in the denominator? Is there...
Oh, I'm just playing. Yay.
That's right. And what's the degree?
Number 20 is no. 19 is no.
Rhymes with
18 is
moo.
no. All the rest
I'm talking to Blue!
That's what I'm saying, sure.
So, 18, 16. You're right. What's the highest exponent?
Looks like a 2.
That's right. That's the degree. And that's it. That's very good. Amber, what do you think about 17?
Wrong.
Is it a polynomial?
Yeah.
Very good. And what's the degree? Muy bien. Colin, what about 18? Why not? Don't say because Tyler said so. Is there a variable in the denominator? Is there a letter on the bottom of a fraction? On 18? There's a Z and a D down there. That can't happen. That's why. Cody, what do you think about 19? Yes or no? Why not? Yes, you do know. I drew both of them on the board. Which of these two things is happening?
Bam.
No. Which of these two things is happening, Cody? The left or the right?
The left. No, I mean the right.
That's right. Square roots. You cannot have a variable under a square root, so it's no. Mike. No. Evelyn, what do you think about number 20?
Yes.
Yes. Very good. What's the degree?
4,
Close.
3.
Even less close. You're getting further, colder. Remember, when you have multiple variables, you have to... There you go. Yes.
Oh, that's right, because you got to add the variables.
That's right.
I forgot.
I want to break my finger. Satchel, what do you think about 21?
Well, not it.
Yes, it would be. And what's the degree?
9.
You only add them if they're like being multiplied. If they're separated by addition and subtraction, you just take the highest one. There you go. Yes and 7. Questions about those?
Number 21.
Fantastici. Here we go. No, you have a question on that one? Okay. No. You sound like Cy.
I figured I'd make it through that.
All right. Only other thing we're going to do today is add, subtract, and multiply polynomials. The only thing that's tricky about these is don't forget to distribute your minus sign. Aww. Which we'll do in Which we'll do in just a second. But first, the trick to adding and subtracting these is simply combining like terms. Very good. So 3x squared minus 1x squared. 3 minus 1, 2x squared. Now notice, when you add and subtract, the variables don't change. Only thing that changes are the coefficients in front of them. Negative 2 minus 4. Minus 4 is negative. You can have a calculator. I advise you to punch it in. 6, that's right. Negative 2 minus 4 is 6. And then what's our, it's just x. And then 3 minus a negative 2. What's minus a negative? Plus. 3 plus 2. And there you go. And there's no way we can combine like terms or anything because...
yes and 2.
well, if that was the question,
No,
yes.
that's just the answer right
But
there.
all it wanted you to do here was subtract. Yeah. And you cannot combine any of that. You cannot combine them in addition and subtraction unless the exponents, or excuse me, variables are the exact same. Which they're not, because one has a square and one doesn't. Questions over that one?
No.
Yeah.
Which
Wait,
is very
I got a question.
Yeah.
Do you
Totally.
put it in the parentheses after that, or just leave it like that?
You don't have to, I mean, you can just leave it like that. You can just leave it like that. Let's see here. Let's keep going. Multiplication. It's all about a big D word. Very good. Distribute.
14.
Alex called this one. Alex, what do I do?
I see what I'm saying.
Your 14's right, but then you have 1x and 2x's, and when you multiply them,
It's 3.
that's right.
Yeah.
All right, now keep going.
Minus 6, 8.
What are you doing?
6x. Yes, that's right. Because you have 1x and 1x, and those combine to be 2x's. Now, Alex, finish it up.
Squared? Oh, no way.
How many x's are here?
3.
Now, how many x's are with this part? 1.
Yeah.
How many are here?
No, so use X.
So that's 1 total. So that's x, 10x. Add the exponents when you multiply. And that's as far as you can go. Stop talking across the class, or I will kick you out on camera. What?
Why is he over by himself?
He wants to be. Okay, questions on that one? What we're going to do now is we're going to multiply multiple terms by multiple terms, but you're going to do it the exact same way. Exact same way. Like this one. Now, your Algebra 1 teachers are going to yell, foil, foil, but I don't...
3 times 5.
I know. But I'm not a huge fan of foiling because the only time you can foil is when they're both exactly 2 terms, which is only going to happen like 10% of the time. So I would strongly suggest you just get used to multiplying every term by every term.
3 times 5.
Fine, Tyler. What would that be?
15Y.
15 was squared.
There you go.
Oh, I get that because it's...
Yup. Now go 3y times 4.
But I gave you the answer, but I didn't
12y.
make no sense.
Pause. All right. 3 times 5, 15. 1y, 1y, 2y. You said it didn't make sense.
No, he didn't.
Oh, okay. All right, so we've taken the 3y by both pieces. Now we're going to do the same thing with the 2. What's 2 times 5y?
10.
There you go. No, just y. There's only one there. And then 2 times 4?
8.
Muy bien. Is this finished?
No.
Can't you
No.
compare the 12 and the 10?
We can combine the 12 and the
You
10.
got minus 12 and 10, don't you?
20.
No, you don't. They're plussed. You plus them. You add them.
You don't do that one thing.
I don't know what that one thing would be, but no.
What's that up there for you?
So you bring the 10 over and change it to mine. But
That's if it equals something.
So we're done now, right?
wouldn't that be y squared?
Ah, where? No, because I didn't multiply them, I just added them. When you just add them, it's just the coefficients. Good question, though. That was a good question, but I said it first, so it's
Sure
to
was.
me, not
No.
Okay.
I have another good question.
I doubt that, but go on.
Hey, Drescher.
I was right. Go. Questions on this problem before we move on? Yes, we can do another one. I'm so glad you asked. I love doing more problems. Click. Now, the reason I said I don't like the word foil.
Because it's 3.
That's right. It is 3.
Do it.
We're going to take these and then times them by these. Now, my personal preference is to take the smaller one and then take both terms and multiply it by all 3 pieces individually. So that's what we're going to do. Who's going to help? Brooklyn, I think you're going to help me with this one, aren't you? Yes, you are. What's n times n squared? Close. You have to add the exponents. There you go. N to the 3rd power. Now what's n times 6n? Now first do the numbers in front. 1 times 6. Okay. N times negative 2. Very good. Negative 2n. Now we've taken the n by all 3 pieces. Now we have to do the same thing with the quattro. And I think Tristan's going to help me with that one. Tristan, 4 times n squared.
4n squared.
Muy bien. 4 times 6n. That's right, n. And 4 times negative 2?
This
Muy
is the
bien.
longest problem ever.
Oh, you haven't even seen. We're going to do some problems this year that are going to take up a page. They're going to be awesome. Really awesome. All right, here we go. Now, combining like terms. There's only one n cubed, so it comes down. Then we have 6n squared and 4n squared, which is going to give us...
10 and 4.
Oh,
Or no, 2, just because they're alike, right?
very good. And then negative 2 plus 24n. Negative 2 plus 24. Another way to think about it is that is 24 minus 2. 22n. And then there's only a number, so minus 8. And you're done. There ain't nothing else you can do to that and there.
Why can't you?
Because
There's a
Never
number
mind.
apparently.
the terms aren't like.
It's also 3.
Good. I was about to explode in fury. Not really, of course. Questions? No. Well then, you wish.
What?
All right. Now, here's 4 examples that I'm not going to make you do, but I do want you to look at them. And if you're like, whoa, Mr. Crawford, why is that the answer?
11.
Then I would be more than happy to discuss that with you. Number 11, y times y. Say the answer. Y times y. Okay.
Y squared.
Yeah. 7.
7y,
10y.
negative 10y.
Yeah.
Now think about that. 7y minus 10y, which is where they got negative 3y, and then negative 7. That's working? Any other problem on the board somebody'd like to see?
Nope, let's use
I guess.
that.
Never mind.
Would anybody like some extra credit?
Me.
Yes.
Awesome.
I need to learn how to do it.
In that case, you two are going to work problems on the board. As soon as I take this phone call, which is interrupting my lesson. Pause. All right, so here's your homework. Those 6 problems, and you need to write them down if you want to watch the video.
Okay, so we can take them over.
Write these